Nice to see. Okay. Here and then it's here and then.
Everyone are getting back, so when you're ready,
Yeah. Okay. Okay. Okay, so I'll try to start. Actually, I can try to speak in Russian, but that's going to be my version of Russian, and most probably you would leave after 5 minutes. So I will just say Меня зовут Sasha, and then go back to English. And I will talk about LiveData and Coroutines. And sadly for me, and luckily for you, Elizarov gave his presentation about Coroutines like 2 weeks ago, or maybe even a week ago. So it's on YouTube, and sadly for me, because I wanted to cover more or less the same material, and luckily for you, because I won't do it, I won't butcher this material, and there will be a link to Elizarov's presentation, so I highly recommend it. It's like an hour of presentation, there's a half an hour of Q&A afterwards. So I will still talk about coroutines, but more why we should start using them or not, and try to show a couple of things that coroutines fans are always doing just to show that coroutines is so awesome and RxJava or threads are bad and shouldn't be used anymore. So so that's that. I will skip this slide. Just my name is I guess on the agenda. I'm Android dev, or actually team lead at GrabHub, and then maybe I won't skip the last part. I'm RxJava fan. So if I will tell something that coroutines are not that great, it's most probably it's because of my deep love to RxJava. Coroutines are great, but hopefully I will stop myself. But if not, then you will be warned. Okay, agenda for today. Hopefully we'll cover everything. LiveData goes first. Then I'll talk about one of the myths that coroutines are so much faster than threads. So hopefully we will all see that it's not the case. Maybe they're a bit faster, but not that threads are just like not relevant anymore. Then we'll talk about coroutine internals, and this part I will try to skip, just show a couple of things, all because of this presentation that Elizarov did most recently. So I'll link this presentation. And at the end, I will talk about coroutines in RxJava, just to show that coroutines is not just like a one-line solution that solves all the problems. And I think that specifically for folks that are using RxJava, and by the way, who is using RxJava? And who is like really using coroutines, only coroutines and not RxJava? So I think I will make my point, because what I'll try to say is that RxJava still should be used, specifically if you have a already existing project, or you spent last 2 years on learning RxJava like me. And now I'm RxJava senior developer, and I'm just a junior coroutine developer. That's why it hurts so much, I guess. Okay, LiveData. What is LiveData? First of all, it's not brand new API anymore, so I think like 2 years old now. The idea is that we have a piece of data that we can observe. What I will try to show is that how it's even possible that LiveData can survive configuration changes, which is of course not true. But the idea here is just to show you how some things that are sold by Google as game changers are actually so easy to implement. Not trying to say that Google just not doing a good job. They are definitely doing a great job, but hopefully we will see that it's all LiveData lifecycle and view model is something that we could create ourselves. And yeah, like I said, LiveData, piece of data that's kept in memory, and the idea is that it can survive configuration change, which is always was a problem on Android, and I guess still is if you don't use LiveData. So this is a sample application, and in this application I'm using LiveData. It's a fragment. As you can see, the important bit is here at the end. So we have a view model. It could be a presenter. We have title LiveData, so we'll talk about this guy in here. And we observed us with that LiveData with someone called owner which is this. As you may know, that's a fragment. So this is a fragment, right? I will focus on LiveData first to try to show how it's implemented and how it survives configuration changes, and it doesn't. And then we'll talk about lifecycle and eventually end up on a view model, and that's not the end, actually. So LiveData. Very simple class, abstract class that we can extend. There is a mutable LiveData that we actually can create instance of, but LiveData itself is abstract class, and all what's interesting in here is just this piece of data at the end, which is in this case not set. There are observers that can observe LiveData, but this is just that. So of course there's much more code below this, but you can trust me that LiveData is just like a behavior subject in a way from RxJava. Definitely cannot survive configuration change. So that's the first slide on my first slide, that LiveData can do that. It can't. So what's next in this line? So if it's not LiveData, which is a simple holder for data, so maybe this is this guy in here, owner, which is in this case a fragment. So let's see what's this /fragment really is. So this is something which is like actually pair of things. It's a lifecycle and a lifecycle owner. So we need to look who is implementing lifecycle owner interface, and what exactly lifecycle is. And what lifecycle is on Android, everyone knows. This is lifecycle, right? I must admit that I'm not Googling anymore, but back in the day I was Googling Android lifecycle, trying to figure out which method is being called after which. And this is of course in case I think activity, but there's of course lifecycle of a view, lifecycle of a fragment, and of course of a service. So this is basically Android lifecycle, and if you were lucky, you could just find the right image. And sometimes they were very similar. There were some bugs in some of them. So that's lifecycle. And in case of a LiveData view model lifecycle and the new architectural components, and this is actually I think the proper one from the documentation. So what Google did, they converted this image into a class called lifecycle that has two enums, event and state, which is not that hard, to be honest, right? Because if we look at the left side, we have some states, right? Like right here, those gray boxes, right? So those states are on the right here as a state enum. And there are like events. So activity can go, the event can happen in here, and it can change of state can follow, right? Another event is this arrow right here, and we have another state. So basically what Google did, they just created a simple class with two more important things in this class. There are some more, but the two important things are those two states, and that's it. Very simple enum. Maybe some of us try to do that to make sure that we don't change UI when after activity was paused. But Google, after 10 years of Android, they decided to convert image into a set of two kind of simple enums. Only funny thing here is that although there are like events like they should be, so events for all the changes in here. So in specifically for the pause, there is an event called pause or stop and whatnot. There is no post state. So this is one thing that is always confusing when you start using that. After a month or two, it's clear. But when you are pause, you go back to created state. When you are stop, you go back to started state. So there is no stopped state. So anyway, this is lifecycle, and as you can see, there is no way of surviving anything in here, any logic about surviving keeping data across configuration changes, because it's basically two enums. So let's see what else we have. So we have lifecycle owner. Let's see who is implementing this interface. So this is more or less a full list of lifecycle owners, which is also not so surprising, right? Because all those things in here basically are having lifecycle on Android. We know about fragments, we know about activities, always struggling with that. There is something new in here called process lifecycle owner, but that's actually a nice way of calling application. So application also has a lifecycle, and the idea of lifecycle for application is just answer the question if the application is being visible for the user on the screen. So if the application is stopped, then it's not on the screen. If the application is started, then it's on the screen. So that's that. Also, there is a lifecycle service. And interesting part here is that lifecycle service just extends service. So again, this is something we could do. Everyone could just create a lifecycle service, extend service, and provide lifecycle. Those two first classes at the top, so component activity and fragment, they are part of Android X library, part of Android itself. So only Google could add some code in there. So in this regard, actually, in this case, it's actually we needed Google to do that for us. Otherwise, someone who had to create a base activity kind of thing. And in this case, it's all included, which is also interesting. You may hate LiveData, lifecycle, and whatnot, and it's still there for you to use because it's included in all the activities and fragments. Okay, so that's lifecycle owners, and at this point we are almost touching someone who is taking part in configuration changes, right? Activity is taking part in the configuration changes. So let's see how it's all glued together. So how lifecycle is glued to lifecycle owner, and how fragment is, in this case, yeah, this is fragment. How fragment is changing, meeting events and changing state. Maybe here we'll find answer how to survive configuration change. So this is perform a pause method from a fragment. This method is being called by a fragment manager when it's changing states of the fragments. And basically here at the bottom we have onPause, in the middle actually, or almost at the bottom, we have onPause method, which is a pause method in our fragment. So when we implement a fragment, basically we implement onPause method or can override it. And when fragment manager is playing around with fragment, we'll call this method during when pausing a fragment, and eventually our onPause will be called. What's interesting in here also, here at the top, we have this a lifecycle registry being called, and method is called handle lifecycle event. So this is the place, in this case, it's on a pause method, perform pause, there's perform start, perform resume. So this is the place where Google added one extra line, or actually one extra line of code to propagate changes of the lifecycle. And like I said, this is the only Google could do that because it's part of Android framework. But it's a simple, actually there are two lines. Anyways, the first one is for view. Okay, so there's, like I said, view lifecycle and fragment lifecycle. Anyway, this is the place when lifecycle changes are happening. Similar stuff is happening in activities. This is perform resume. I will skip this, but it's a very similar one. But still, there is nothing that is holding any value, like LiveData, for instance, across configuration change. Right now, we are only seeing how it's all glued together, how events are sent out, like lifecycle events, and states are changed. But still, we are not sure how to survive configuration change. So what else is in here? So we covered LiveData, a piece of data. We covered owner and lifecycle, so basically fragments on all the states that can be done in the lifecycle and now being converted to enums. The last thing that we can have a look at is a view model. So maybe a view model is someone who can explain how to survive configuration change. So let's have a look at a view model, and sadly not. The view model is the simplest class of all of them. Is just an abstract class, not doing anything, only just having protected methods, so it's not required one. So a view model is just nothing. And what we are doing, we are just extending view model. So definitely, if there will be any logic that can survive configuration change, it's not in LiveData, it's not in lifecycle, so it has to be here, but it's just a comment, right? So it's kind of surprising because view model is just nothing. And then if you go back to the slide, who else is playing, like helping to survive our configuration change? So definitely it's not here. Who else is in here? We see, or hopefully you can see, that here there's something called view model providers. And view model providers, there's a method called auth, and we pass a fragment as a parameter, and then of course we get a view model back from that call. So maybe this is the place we can have a look and see how configuration change can be survived. So let's have a look on view model providers. And there's a slide back in here. So here is a fragment. Here I have an activity, but the very same principle applies in here. So we can get a view model provider out of activity or a fragment, not much difference. Anyway, a view model provider, as you can see, which is funny, we provide a fragment activity to a view model provider, and then we just create a view model provider and reaching out to activity to get a view model store. So it seems like we could pass a view model store in here without passing an activity, but actually this is a hint. Because activity is something that can survive configuration changes most probably. Actually, this is a strong lead that we have to look into an activity, right? Because what's happening in here is that we have a view model provider that is being created out of a view model store, which is inside of an activity. And by the way, view model provider is just a class that is it's there as an interface. It's not doing much. The whole magic is in the view model store. So before I will go to the next slide, what is a view model store? So view model store is a place we can ask to create a view model for us. And basically, it's a hash map. A hash map that holds a key, a class of a view model, and a value of view model. If there is no, an instance of view model. If there is no instance of a view model, and we ask for a view model, a new one will be created for us, returned, and of course added to that hash map. So view model store is just a hash map. So let's go to the next slide. And this is now a get view model store method inside of an activity, and the whole mystery how to survive configuration changes if you are a live data is right here on this slide. If you have a look at this if in here, we have something which is a nicely named non-configuration instance. And we can get last non-configuration instance, and maybe inside of that, so that's called now NC, inside of that maybe there is a view model store. And I will cover this API in a second, but hopefully you can see now that activity, and we are in activity, when returning a view model store, and the view model store is not available because let's say activity is starting, or is like restarting after or being recreated after configuration change, can reach out through this API and get back something that was obviously passed by passed to a similar named method. So let me show you how actually it looks like when activity is trying to store view model store during configuration change. So there is a method called onRetain non-configuration instance. And inside of this method, there is some magic happening, but eventually a non-configuration instance is being created, and a view model store is just then passed there as a reference. And then that's being returned to Android framework. What's happening in next step, Android framework is killing activity, but now it's keeping handle to this view model store. So once activity is being recreated, in the next method, so in activity on create, activity can ask through this method if there is an instance that survived configuration change, and if there is one, please give me that instance, and I will just take my view model store out of it. So the whole magic of surviving configuration change is not to be live data, it's not to be a lifecycle aware, but it's to be a view model that is being created through a view model data store. So that's that. It's basically a hash map. That hash map could keep everything in memory. It's only keeping view models because there's a method to get a view model, and that's the only method that hash map has. So we cannot put anything else in there. But the whole magic of surviving configuration change is just a hash map that's kept in memory, keeping references to all the items that are supposed to survive configuration change. And there is this one API call. So the question is this whole magic was this whole magic only available to Google developers, or maybe we could create a similar API ourselves? So sadly, we could do it ourselves. So this API is available from support fragment, so support library 22, but also there was one available since API level 1. So it took 10 years for Google to use API level 1 to provide us with a really nice way of surviving configuration change. And it actually we could do it ourselves because API was there like since day one. And the best part is there is information that we shouldn't be using it, and yet Google is using very similar API, but not in Android itself, but rather in a support fragment library. So to sum it up, 10 years it took them. Hopefully they were doing something over those 10 years, and now everything is done, so they can focus on high-level things and provide us with new APIs and Kotlin and whatnot. But it took a while to reuse this very simple API 11 call to just create this view model thing. And the last thing, which is, I guess, I think the biggest joke of all of it is that the thing that is surviving configuration change is called a view model. And basically, it's not doing anything. It's just a abstract class, right? It could be called someone that can survive configuration change, for instance. And a friend of mine is using MVP pattern, but he also wants to use this mechanism to survive configuration change. And in his code, and even he showed that during a presentation on a stage, he had this, login presenter that extends view model, which looks really suspicious to me. But sadly, this name it's not that great name, because we have view models at this point. We have view models in MVVM pattern. We have view models when you use data binding. This is like Google how it's calling those data binding objects that we pass down to XML. And now that we have third view model, which is part of this LiveData/Lifecycle API. So that was the first thing. How easy actually it was, and kudos to Google for doing that. The second topic, the second thing I wanted to talk about how coroutines works, and maybe they are also as simple as that. Truth to be told, they are not. But sadly, like I said, Elizarov gave his presentation, and I will cover a bit of that, but there will be a link to his presentation. But what I will cover now is, I would still talk about coroutines, but rather about things that people are always, I think, like abusing in presentations and trying to sell coroutines as a tool to solve all the problems, and by basically blaming threads for being heavy, slow, and whatnot. So typical example that you can hear on a presentation, it's even in documentation, there's a link in documentation, that the coroutines are cheap. You can easily create 1 million of coroutines, and there is no way to create 1 million of threads, right? And this is actually kind of obvious thing, and I cannot imagine anyone trying to do that. I think even Java is like by default using up to 8 threads, or it's dependent on how many cores you have in your all the schedulers in schedulers.io. Anyway, everyone is creating pool of threads and executing all the jobs that are to be executed on that pool, not just creating a new thread, because it doesn't make sense. But still, in the documentation, they suggest that we all create threads for each and every code we want to execute. We don't use threads, thread pools. So actually, this is exactly the example from documentation. As you can see here, we have just like a loop. That in that loop we just create up to 1 million of threads, and here we just have coroutines. And according to this documentation and many presentations, this will work, and this won't work, which is kind of obvious. And I will show you actually why this is not that great example. And basically, that's both things are very similar, like threads and coroutines. And but the example is just flawed in a way. So and this is a thing that that helped me to prepare this slide. Basically, it's a Kotlin. So this example is Kotlin documentation that is just here saying that maybe one thing. So when someone saying that there are lightweight threads on JVM, obviously there are no lightweight threads on JVM. They are just threads because we are on JVM. So one thing is to name something like lightweight thread, and another thing is then implement that using something. And in documentation, somewhere here we have information that maybe I'll look at my screen. Here at the bottom, you see that the default dispatcher, so something that is executing all the coroutines, is just using a pool of threads, because there is nothing else on JVM. So it has to be a pool of threads. So coroutines are also using pool of threads. So this example, I will go back here. This example you can imagine is there is a pool of threads executing all the coroutines, and here someone just trying to create 1 million of coroutines. So let me show you my example. Why many people are just, I think, missing the point when trying to compare coroutines to threads. So I will do the same thing. I will try to do something, create 100 coroutines and threads, and we'll see which one will be faster, coroutines or threads. So my example is as follows. I have application, basically a hello world with a button. And this application, if I tap on a button, I will just call a main method. And in the main method, make it a bit bigger for you guys. So I will count things just to make sure that all the threads or coroutines finished working. So I will just count them. I will make something actually. I'll make a network call, not to add things and see that there is no time difference. I will make a real network call. I will just fetch example.com. Hopefully they will be okay with that. And main method will do two things. First, I will run coroutines and count all of them and measure execution time. And then I will just reset the counter and again do the very same thing with threads, okay? And the way I do it with coroutines is kind of simple in the end. So I do run blocking because I want to measure the time of that and not to finish the method at the end. I need to also update UI with with the real values. So I will block at this point, but on the UI part, because here inside I will just run on the UI threads, repeat 100 times start coroutine on the global scopes. So that's going to be IO thread, sorry. I will fetch data using Coro method to fetch data, and then that's going to return 200 OK, and I will count all the 200 OK. So I'm making 100 calls, I will get 100, 200 OK, so I expect the C to be equal to 20,000. I believe my math is right. I will wait for all the coroutines to finish, and at the end I will know how many values were, so how many 200 OKs I got back in the response and how long did it took, okay? So very simple code. So maybe lots of boilerplate around, but the gist of it is 100 coroutines using global scope, fetching data, adding values, and then just checking how much time I spent on that. And then here is a trick I will do that everyone is doing like now. So it's not any trick. I won't create there's similar, this is the same stuff, but in threads. I won't create 100 threads. I will just create a pool of 4 threads. It's a normal thing. It should be, I guess, the number of threads should be depending on how many cores or CPUs I have, like in this Mac or on my phone. But I will just create a pool of threads. The same thing that coroutines are doing. And the rest is more or less the same. On that pool of threads, I will just 100 times try to execute something, which is a blocking version of this fetch method. I will again add all those 200 OKs and I expect C to be equal to 20,000. I will tell executor, please shut down after you are done with all the work, and I will wait for this shutdown. So definitely at this point, all the threads should be done with the work. And again, I will update UI and see how much time I spent. I expect in both cases C to be equal to 20,000, if my math is right. As you can maybe see, start button is blocked, and that's expected. But now in the background, I'm making 100 calls using Coros and 100 calls using threads. It's going to take like 16 seconds, hopefully. And I wait, and I wait. And we have our result in here. So this is a real example of how thread-based code launching 100 calls to fetch some data using 4 threads, and it is working against coroutine code, also starting 100 coroutines, but keep in mind, being executed on a dispatcher which is backed by 4 threads or like some other limit, but a limited amount of threads. And in this example, I have the same value of C, so definitely 100 calls were made because I got 100, 200 OKs, and I added all those 200s, that's 20,000. The time difference is coroutines were a bit faster, like 2 seconds faster than threads. I can switch from 4 threads to 8 threads, and of course, outcome will be like threads will now be like much more faster. But what I'm trying to, my point here is, don't believe that coroutines are faster than threads. The only thing that you can believe is that don't create 1 million of threads. But that's it was like this since day one, right? So that's nothing new at this point. So that's one myth I wanted to hopefully get rid of it. And now I'll just slightly touch on how coroutines work. And like I said, it's all because of Elizarov. Oh yeah, by the way, this is his presentation. I even stopped in the right place for you guys. So if you really want to see how it works, definitely he is the right person to explain that. I will try anyway, just to show you one interesting thing that I think he skipped in his presentation. I will try to post those slides online, so like on Facebook page or something. So, but still, it's a Kotlin Coroutines 1.3 Q&A, and so that's easy to find on YouTube. Anyway, how coroutines works. The best way to see how coroutines work is just to create one coroutine yourselves. And in my example, in this app, I created a simple coroutine that is just wrapping OK HTTP call. So as you know, OK HTTP is just basically using a callback interface, right? So we just create an instance of a call, and that instance, when I enqueue a callback to that instance of a call, the callback, so that's enqueue method in here, I will get a response or a failure. So callback can give me a value or an error. And to wrap that as a coroutine, there is a helper method provided by Kotlin library, which is called suspend cancelable coroutine. There is also version without cancelable. And basically the way to create a coroutine is just to use this tool that out of blue will provide us with something called continuation. And this is the big thing behind coroutines, continuation. So to create a coroutine, your code is supposed to block at some point in time because some more data is needed, some computation will be done wherever, and then eventually you will continue. In this case, I'm taking this continuation, making a call here. Eventually, I'll get value back on response, and then I can resume continuation. Just continue executing the next line in the body of a coroutine. If there is a failure, I can resume with exception. The best part, this is old API. Now all the methods are called resume or resume with and taking, I believe, a result. And this is just a syntactic sugar just to be backwards compatible. But to create your very own coroutine is as easy just to use a helper method, the suspend cancelable coroutine that will give you continuation, okay? So that's one way of doing that. So how about we'll just create, and sorry that the code at the top is small, but the important bit, this is a valid coroutine. But to see how coroutines actually work, you can watch presentations or check it yourselves, which is kind of simple. Just go and start in Android Studio or IntelliJ, just go with show Kotlin bytecode, and everything is there. And basically, it's also a good tip if you want to see what Kotlin is doing with your code and how it's being converted to Java itself, or actually to bytecode. So on the left, I have my very simple coroutine, which is having 2 suspension points. It's kind of small, and this part is definitely kind of small, but hold for a second. Anyway, this is a simple coroutine, 2 suspension suspended functions, sorry, 2 suspension points inside. I'm taking a parameter string and returning value string. Inside, I think I'm fetching some data from GitHub and waiting 5 seconds. So a very simple coroutine. Here on the left, this is what you can really see when you open this show Kotlin bytecode thing in Android Studio. And this is a bigger version of that. So sadly, it's not as colorful as normal Kotlin code. But what's interesting in here, as you might remember, my method was only taking one value, a string. Here, out of blue is taking also a continuation, a second value, right? And it's here returning object. So what's happening in here that when you want to create your own coroutine, you can use helper methods, and those helper methods will give you continuation. And then with continuation, you will just resume with error or resume with a valid response. But when you just add a suspend keyword to your function, someone has to do the whole magic with continuation for you, right? So, and this is what Kotlin compiler is doing. Kotlin compiler, when we just create a coroutine and method and add a suspend in front of it, will do the very much same thing. We just add a continuation as a parameter to our function, change a lot of code inside, but essentially will block in all the suspension points, and depending on the value returned by each and every suspension point, we either continue with result or with exception, and there is no magic in there. What's interesting and cool is that coroutines are meant to stop callback hell, right, and make our code look sequential, and they do that. But when you look at what they are doing under the hood, they are using callbacks, and continuation in particular as a callback, and then basically doing things that they were supposed to help us with. But of course, we don't see that, and that's the actually great idea behind coroutines, that all the magic is done by a compiler. What's maybe interesting in this code is that actually you can understand it if all those things are in the JVM documentation. I spent some time on that. Some things are for me not that hard to understand. Lots of magic still there, but I can assure you that it's like nice Friday evening, or maybe 2 nice Friday evenings, and it won't be scary anymore. What's interesting here is that, like I said, my method is not my method anymore. Out of blue, it's getting continuation as a parameter, or as a last parameter if there were like others. In the code in here, you can see there is something called label, and we'll go to that in a second. But this label is so. Depending on how I will show in a slide, but basically the whole code of the suspending function, our coroutine, is basically one giant switch. And this label is this value of a switch, or maybe in Kotlin language, it's a value that we pass to when, because that's how it's called in Kotlin, right? So anyway, label is just changing value from -1, 0, 1 to, and then depending on the value, we are just going to next part of our coroutine. So I can imagine that if any of you would create such a method, there's no chance that this method will pass review, right? Adding switch, giant switch state machine, that's a surprising thing to see nowadays, but this is what's under the hood. So extra parameter, this magic label, and let me show you the switch. So that's another slide that's hard to see, but I'm prepared for that as well. So here, in my case, I have only 2 suspension points, so they are marked in here. And in this label, I have like 3, sorry, in this switch I have 3, and there's default 4 labels. So 2 of those are just for to jump to my method and continue then to another one. Also, as you can maybe see here in the code, actually my method is being called. So it's not like I'm talking bullshit in here. So definitely there is a label. This label is being used to jump to different values in this switch, and eventually my code is being called. And the final proof that coroutines are changing your code into one giant switch, or when, if you will, is that the more suspension points we have in our code, right, the bigger this switch is getting. And this is a bigger version of that. So I added a handful of suspension points, and now it's getting bigger, bigger, and bigger. And the best part is actually this is kind of optimal way of doing things, because we don't have to create any instance of subsequent code. We have just giant switch. Switching to next like label of that switch is kind of fast, and the continuation is being passed over and over again. So in a way, this is kind of efficient way of doing things. It looks ugly. So more details are in Elizarov's presentation. Also, I'm not sure why I don't have the slide in here. Also, there is a mobile optimized conference in here, I think this year. And there was a friend of mine talking about coroutines, and I think he also covered this topic. Definitely, if you go to YouTube and look for mobile optimized coroutines, so basically mobile optimized, great conference, and specifically this year's edition, there will be a video about just coroutines, and I think the outcome will be the same, because there is no difference. You will see the very same switch, but in a different way. Okay. And there is last thing I want to touch. I have still 5 minutes. Hopefully there's enough time. It's a question that I'm trying to answer myself. I'm using RxJava. I love RxJava, and basically I love this. I'm not scared about those kind of code, right? Coroutines look nice, but this is my bread and butter. And the question for me is, I'm trying to answer, is that really, do I have to switch to coroutines? Definitely, we all have to learn coroutines, because if you want to call yourselves a senior Android developer, maybe even backend, but coroutines are also on backends, you need to know coroutines and LiveData, all this stuff, because this is what expected from a senior that's supposed to know everything about current Android, right? But the question I'm trying to answer is that, do I have to switch like immediately to coroutines and stop using RxJava? Will my code be simpler? So what I did was actually I was playing around some bullshit application I created for this presentation, more or less. But what this application is doing is, this is like my typical RxJava stream. So of course it's not in activity, but to make it simpler, this one is in activity. So I have an activity. Inside of an activity, I have some views, and then there will be a method called. And in that method, I will start a stream, right? And I'm doing that. I'm just making a call that's a single from callable. So I'm just starting a blocking method to fetch data from a network, do some computation, whatever I want. I'm fine to spend as much time as I want in here, because that's going to be run on the backend thread. Why? Because here I asked for that, right? And then, of course, I will consume this. I want to change label. The outcome of that will go to the UI. So I'm saying, please post that on the UI thread, right? And of course, I want to clean up after myself. So I'll just catch this disposable returned by subscribe. I added composite disposables, and on destroy, I will clear all of that, right? So this is the way I'm being more or less Android nowadays. Lots of streams, not in activities, but my bread and butter. If I want to make something more complicated, there are like lots of operators we can use here, like zipping, flat mapping, whatnot. But this is I would say definitely most of us are doing RxJava and our bread and butter. So how does it look with coroutines? Do coroutines really change like completely how the code looks like? So this is my first take on that. So basically, if you look at this method, this is the same thing. So I have a method, when I have a UI, when I tap on something, on start, and there is a button in that activity, when I tap on start clicked, I will launch something on a global scope. So that's a new thing in coroutines. But I will launch a coroutine. That's a coroutine builder, right? So in a global scope, I will launch. I need to tell that I want to consume that on the UI thread. So just like with RxJava, you need to tell, I won't get bugged that on the UI thread because I'm about to change UI. So very much like in RxJava. I will launch, in this case, it's a coroutine. So this method cannot be a blocking one, but it's not hard to create a coroutine. Then, of course, I will change UI. I need to get a hold of a job, because at the end, I need to have a reference to a job so I can cancel it. So if I go back and forth, very much same ceremony is needed for coroutines. We need to launch something just like to create a single from callable or like to create a stream. We need to have a reference to clean up ourselves. And very often we need to tell to coroutines, just like to RxJava, where to execute things and where to consume them, right? So the only thing that is interesting, or maybe is actually very interesting, is that the middle part, in case of coroutines, the more complicated it gets, the more readable it stays, right? Because if I want to launch two coroutines at the same time and wait for both of them to finish and then aggregate return values, I can just very easily use a sync there, and it will look kind of nice in here. For me, using a single zip in here is also kind of nice, but I can agree that for many newcomers to programming that never played with RxJava, coroutines might look nicer. And the last thing, actually, just to be honest, this is a layman's approach to coroutines. This is the, I think, nicer way of doing that. So as you can see, now my activity is coroutine scope. I'm not sure if it's available only in the latest version, was it previously, but now my activity or my presenter or my view model is something that is plenty coroutine scope. So all the things where to hold a reference to a job, where to execute and consume result can be stated in one place, okay? Then I don't have to get a hold of a job, and I don't have to provide a global scope because scope is being created for me using this context in here. And at the end, of course, I still need to clean up, but it looks a bit nicer, and everything like the configuration part of the coroutine scope is in one line. But still, the ceremony more or less the same. Something has to be set up, something has to be cleaned up, and the magic is maybe here in the middle because the rest stays the same. And I think that's the last slide. Not sure why it's not switching. Okay, something's broken. Anyway, what I wanted to say here when comparing RxJava to coroutines is don't ignore coroutines because Google is not ignoring them. Google developer advocates are talking about them, and we want to be seniors, right? So we need to know them. But if your code is using, just like mine, RxJava, don't be worried. RxJava is fine and will be fine, hopefully. But yeah, eventually coroutines, I guess, will win thanks to the power of JetBrains and Google pushing them forwards through developer advocates and blog posts and whatnot. So that's that. Thank you very much.
All right, folks. Thank you very much, Aleksander. So now we have some time for questions.
Are there any? About RxJava, please, because I'm not a coroutine expert, to be honest.
Aleksander, thanks. Can you please explain? It's really hard to me and confusing to map the Kotlin concepts around coroutines on my basic knowledge about coroutines as a computer science concept, like which is related to cooperative programming and that sort of stuff, basic stuff. And can you please explain, for example, what does it mean, like coroutine scope? What does it mean?
I'm not working for JetBrains, so I'm not pretty sure. But you can, so I can imagine that they wanted they want to improve Kotlin, right? And Kotlin is just copying features from top players. And there is C# having coroutines. There is a yield keyword in Python. So coroutines are here because they want to prepare awesome language for all the use cases. So that's why there are coroutines in first place. If their take is just to be like an academic one or just to create something that is practical, I think they go more like into practical direction. So I'm not sure how to compare that to academic approach. If it comes to a global scope, this is a new thing. And the idea was that you can have a coroutine nested in a coroutine and in a coroutine and so on. And with global scope is that like scope is being inherited by the child coroutine, so to speak. So if you are about to cancel something from the top, everything that's inside will be canceled as well. Also, exception propagation will cancel things. So coroutines were introduced like most recently. Previously, there were no idea of this scope. So basically, I think you can create your own scope, and the global scope is like global scope. And by the way, scope is just basically a set of things. So a job, so you can provide a job. So all the coroutines sign to this job, so I can cancel all of you through this one handle. So that's that. Exception handler can be part of this scope. So there are like 4 coroutines, and I'm not sure if and how they are managing exceptions, but I want to have all those exceptions in my one particular exception handler, and I will handle that there.
What do you mean by saying 4 coroutines? Like coroutines builders, like launch and all others?
So launch is extension function on top of global scope now. So it used to be just launch. Now it's global scope.launch. You cannot have launch without like global without a scope.
Okay, it's still pretty confusing, actually. Yeah, just to make it clear, the syntax you used is not exact syntax that is up to date, right? I mean,
this one is super up to date,
so, yeah,
and this one is this one is as well. As you can see, hopefully you can see here. Okay, so here global scope now it's required. Previously this one wasn't needed.
Yeah.
Now it's global scope, and there is a job. If I cancel this job, everything in. If I use async in here, I can wait for all the coroutines to finish. This is what I showed in here. Let me just quickly jump to Android Studio. Maybe this somehow will make it clearer. So here, where was that? In here. So even though inside here I have a launch without a scope, but of course it's like having this global scope, right? So here I'm launching 100 of coroutines, and with just one handle I can wait for all of them, because they are just scoping to one thing. So the global scope knows what's inside, and if I tell to this deferred, please await to finish, then it will wait for the 100 coroutines to finish.
Okay. At least now it's more clear. Thanks.
If you have more questions, I'm happy to take them if I know the answers, of course. So once again, thank you very much.
Okay. Great.